7 war.
Okay, so we are live. We'll give everybody a couple of, or 1 or 2 minutes to join in, just to wait, to give people a chance to join. And then we will start in a couple of moments. The recording will already include this part, so we'll see. And looks like we found a couple of viewers. Welcome, everybody. Hi, thanks for joining. Before we start with the official part, I'm Philip. I work for Elastic. I'm part of the community team in Europe. We regularly host these meetups, as you might know. And today we have 2 special guests from Zurich who get along so well that they wanted to share one single video camera and wanted to be in the same picture together. So it's almost like an in-person talk where the speakers see each other. And I'll give it 1 more minute and then we will kick it off with the actual content. In the meantime, if you have not seen it, we have started planning the community conference for Elastic in February. And the CFP has opened now. So if you want to speak there, submit your talks. They're open until the 24th of December. So we hope everybody makes it before Christmas. You can enjoy Christmas. We'll pick the talks and then we'll dive into the content. So, and with that, Martin and Jens, are you ready?
We're ready?
You want to share your screen and then I'll hand it over to you and it's your show.
Okay, thank you, Philip. Share screen, share screen, share screen. All right. So, siehst du, was wir sehen?
Yes.
All right. So, welcome everybody. My name is Jens Witzel from Zora IT, and together with my colleague, Dr. Martin Brändle, we are working on a very short introduction to our project that we call Zurich Open Repository and Archive Zora Goes Elasticsearch and the Kibana, and we want to show you a use case at our university, how we did all and managed all the things to index, search, and analyze universities' publications. And what can you expect in the following 30 minutes? Well, first of all, just 2 slides of who we are and what do we expect from Elasticsearch. We show you something from the user's view. That would be a hands-on, a live and color presentation. After we explain the technology and the software we used, and Martin then will take over and tell you something about how the data came into Elastic, and he would talk about the potential of Kibana, which is very interesting on monitoring at our university, and even more live and even more colored. And after all, at the end, we want to take a quick look into the future, what we are planning. So let me just explain what is Zora. It's the short version of Zurich Open Repository and Archive, which provides open and worldwide access to research results of the University of Zurich. We have actually last month nearly 160,000 reviewed publications. So it means we offer full text or metadata, and we interact with other publication sources like Crossref. So we interact and interchange our metadata. This all is a container. Zora is a container for different uses in our university. For one example, it's the basis of an academic report. And last but not least, it's the source, or the source of a publication list on the web. So we reuse all this data multiple times all over the presentation or the web of University of Zurich. We're doing this Zora job, so we're operating it since 2006 by the main library together. We from the central IT use this, and yes, we had problems with our search engine. It was weak and no longer up-to-date search UI, what we can offer, and we were searching for another solution. So we found out that Elasticsearch would fit our belongings. Of course, you know, it's a shooting star of the search engine scene, and it's high performance and fail-safe infrastructure. And Yes, we were searching for a graphical user interface, and we found one which supports facets, filters, auto-suggestion completion, highlighting snippets, multi-line analyzers, and many more things, like this mobile displays and such things. And we want to show you what we made out of this. And in the second part, Martin will show some more additional features from the Elasticsearch Elastic world, which is Kibana, log file analyzing and monitoring. So don't talk about it. Let's go live into the Zora universe. And so therefore I have to change my browser and go into the Zora universe. As you see, this is our repository. It offers a lot of publications, and what you see is that Elasticsearch is just connected to this small input field here on the top, which is installed in every single page, every single service page, single view, and things like this. So we can also use it as the first front end if we take something like some search terms like COVID, COVID pandemic, for example. As you see, we get a lot of auto suggestions in the part below, and as you see, it's highlighted, and of course we get all the results when I use the enter. That's our storyboard. Our storyboard is used like this. We just offer the input field and always come into this landing page. So the landing page of search is what you see here. It's more or less, yes, 3 parts that you can see. On top, again, the input field. On the left side, all our filters and facets. And on the right side, you see the results, which are, yes, mostly split into 2 parts here, an information part and all the results as a list with some citations and additional information. So we want to go to some short scenarios. As you see, when I'm searching for COVID and pandemic, you see it's an AND combined search. So we are searching for all publications which have the word COVID and pandemic inside all metadata. It means the title, author names, PDFs, full text, whatever you want, the abstracts. And as you see, we can sort the result through different parts here, like relevance, ascending order, or descending order. We can also export it to different bibliographic formats. For example, we can export to an XML version so that the user can take it over for other usage. And this status bar, as you see, is which is a result list. This was the export. As you see, it's an XML export. It just has to be formatted through the editor. Oh, it needs too much time at this moment. And as you see, this is one single result, which means in the title there's a COVID, there's a pandemic, this was the author or editor, this was the year of publication, and there are some small snippets under each result. Where you can see one is the abstract, and the second one is just a part of the full text which fits to the search terms that we fill in. And what you see here, the abstract, or more or less the full text part, the snippet here, is totally context central. So the system knows whether we're logged in and staff member of the University of Zurich, or if we are just a guest. And as you can see, all our publications have a specific status, which means this is a locked publication or an open source, an open access publication, and it depends on the status of the document if we show all these parts, because metadata is always open to our customers, but if an access to a publication is closed, like this one, then we do not offer snippets from the full text. Okay, this is the part how we make our citation. This is the typical part that we took over from our old search engine. Here's the status of the document, and Martin will tell you something about it more later. And yes, this is the publication itself. It's mostly in a PDF, and you can access to it if you have got enough rights on this site. So on the left hand, you see all our filters, all our facets, which are really easy to understand because year always means the publication year. The name is mostly around the author or the editor. And then we have got communities and collections. We've got the type. Is it a journal? Is it a book? And you can see which access rights we have, if it's inside a journal, or do we have different languages of the publication or the affiliation of the author. And yes, as you expect, we can filter now and let us show only COVID pandemic, where the publication year was 2021, and so on and so on. So you can combine all the filters, as you know. And if the filters list is too long, you can also make something like a filter function here that you can that you can filter also the filters. That's all. So some of the code is coded by ourselves. Specifically, this kind of behavior, who wants to see or who is allowed to see what. But this one is from the UI itself, which we later link and presentate where we've got it from. And all these functions like more or filter or show them. It's a combination. It's a easy to understand and use React code. Yes. So that's all. To select the facets, this is the heavy part of the story, because if you have got customers who want to see specific filters, you have to make a brainstorming before. But luckily, we had a lot of metadata and a well-structured format with our publications, so we were easy to find some filters and collect them into groups. All right, so now come back to the search terms. I just want to show you that it's possible. This is always possible to use some more structured commands, like the opposite of this always used and combination. You can also use some specific words like COVID or pandemic. So you want to see any publication which is included with COVID or pandemic or SARS or whatever you want. And you can also go down to every field that we put inside the Elasticsearch index. Probably we want to see from the beginning COVID, but only where the publication year was 2021. And if we're searching for this, you can also see it in the facets that it was that it has only these results, and it's in this case 569. So what can you expect also from this? Just two more hints. The first one, that's why I prepared this tab, is you can also make this on your mobile phone. It's just a different way of presentation. Here it's called show filters, and as you expected, these are of course the facets, and you can choose some of them and save the filters, and then the result will change immediately. And on the second, that's a little special thing in our Zora universe that we offer. I killed the wrong filters. That we offer some formula notation, which is always interesting for physics, biologics, and chemical colleagues. And mathematics, of course, yeah. So that's for the moment. You're invited to visit our homepage. It's www.zora.uzh.ch, and you will find a lot of possibilities to test our search environment. All right, now to the interesting part. What kind of technology or software did we use? On the one hand, of course, it's the Elasticsearch itself, the server, and on the other hand, it's a client. It's a React-written JavaScript client which we use, and the data flow is the following: the client could directly talk to Elasticsearch, but we did a man-in-the-middle attack with our Zora proxy. The client always talked to our Zora, and Zora talks to ES, to the Elasticsearch, and the way back also. I will explain it in a few seconds. At first, the client is doing a query, and he is telling the Elasticsearch which facets he wants to see. And then Zora is doing a kind of logging and a kind of authentication, because our Elasticsearch index is not open worldwide. It needs an authentication. And then the query and the facets are forwarded more or less one-to-one to the Elasticsearch, and the Elastic collection will give a feedback. And then the results of the facets, they were given back to the Zora proxy, and we add on some special language, phrases, citations, some snippets, depending on if somebody is the UZH staff or he's logged in or something like this. So the result has to look a little bit different. And then we give it back to the client and make some CSS power work and some React things. So that's for the moment. Martin will overtake and show you how the index process worked. So how we did all the Zora metadata into the Elasticsearch.
Hello together. Okay, so the data flow for the indexing process goes along a similar line. Actually, the base software of Zora is EPrints, and it provides an event queue for tasks such as indexing and other tasks. Indexing is controlled by two components. So we have the client that sends an index trigger to the task queue, and then the task queue is calling a plugin that provides the indexing methods. And this plugin is just using the Perl search Elasticsearch library to communicate then with the Elasticsearch cluster. The script works similarly, but there is also an option for direct indexing that bypasses the event queue and calls the plugin directly. And of course, this way we gain some performance. So what happens with the data? Actually, Zora has two containers of data. There's a MariaDB database, which comprises about 50 gigabytes of metadata and administrative data. And then there are the documents which reside in the file system, which of course are administered by the database, and they now fill about half of a terabyte. Both of these data containers are transformed or excerpted into one single Elasticsearch index, which is about 34 gigabytes. And this is, of course, much less because the documents, they contain pictures, images, graphs, which are not excerpted. And so that's if I can read. That's the way that we can reduce the amount of data. As Jens already told, the metadata in Zora is highly structured, and it has, for example, fields for titles, authors, and other bibliographic data, and also for nearly every record we know the language. The mapping, which just is written here coarsely, of the Elasticsearch index is as follows. There are fields for aggregations, and there are fields for the mapping, for the bibliographic metadata. Then there are document attributes also that we save as well. For example, the open access status, to which we come later. Then the full text are stored, and as well the citations are stored. So the citation is what you see then in the list of results, actually in the top 3 lines. So because we have for most of the documents the language, and the document may even have several languages, we use language subfields that apply then the corresponding language analyzer of Elasticsearch. And we do so for English, German, French, and Italian. And for other languages, it just use the default analyzer, but that's easily extensible. So if one day Spanish or Japanese or Chinese would prevail, then we easily could add this language as well. And this we do for title, for example, for the abstract, the full text, and many other fields. So, as Jens already also said, software has been developed by us, and we provide a control script that allows to create an index, to delete the index, and also update the mapping. It also allows to reindex the data, which takes about 24 hours for 150,000 entries. We think this is pretty fast. It's 10 times faster than with the previous search engine we had. And also it allows to repair the index in case of differences or if we had downtimes because of some maintenance. The main workhorses, however, are the plugins for the proxy, for the query proxy and the indexing, and a lot of configuration files which provide the methods, the aggregations, and the triggers. The code itself is quite generic, and it can be used by other EPrints repositories, and we have provided that back to the EPrints community. Now we come to the potential of Kibana and Elasticsearch. And as you see, we had made very good experience with Elasticsearch, so we wanted to go a step further and investigate the potential of Kibana and Elasticsearch for the analysis of research publications. There's a large interest by the university's main library and also other university libraries to monitor the success of their investment into open access. And open access is somehow movement. It means that research publications should be freely available to the public, so that the research publications are not based anymore on a subscription model by publishers, which the more and more gets more expensive. There are 4, sometimes 5 ways to classify the access of publications. There is gold open access. So the author or the institution or a funder pay the publisher a charge, and so the article becomes open. Then there is green open access. This means just a version of the article is made available via repository if the author is allowed to do that. And then there's the form of hybrid open access, which is a combination of the subscription model and paid access. And this is not very liked a lot because you pay twice. You pay once as a library for the subscription, and the author also pays that the article gets open access. And then, of course, there's closed access. So we developed, together with the main library, an open access monitor that allows to analyze of the university publication some key figures for open access, so the open access status, as I told just, and the costs and other parameters. And also it allows to analyze by the organizational units, university faculties, institutes, by the authors, publishers, and journals. In the open access monitor, it's the idea that everyone can look at the numbers. So we provide publicly accessible dashboards with visualizations. It should be compliant with the Swiss National Open Access Strategy, which also mentions monitoring as one of the tools in its action plan. And our aim was twofold. First, to evaluate open access. What's the state of open access at the University of Zurich within the departments and so on. And also the idea is then to promote the open access at the University of Zurich. If you know that the numbers are transparent, then you can also then really figure out how to improve them. And one side effect was that we can improve the quality of the publications with respect to the open access at the same, with respect to the open access. So let's go to the demo. How can I switch? Just like this. And then just go there. Thank you a lot, Jens. Let's go back here. Good. So I have to reload this one here because now the session had timed out. So this is a startup page of the Open Access Monitor. It just gives a raw overview of some key figures. Still loading. Okay, here we have it. And for example, you can see, okay, open access and between 2000 and 2000, open access share between 2008 and 2021 was around 46% on average. And yeah, it's on 170,000, nearly 130,000 documents. You can move the sliders. This is just for a quick overview, and it will adapt immediately. But let's look at 3 use cases, and we start with the page on the faculties and institutes. That's what I'm wondering now. Okay, it should close. It's still loading. And here you see the distribution of open access, again from 2008 to 2021. You see here the colors, gold, green, hybrid, and closed. And this is the distribution actually over the years. And now let's look at a given faculty. I'm just asking what's the open access share of the Faculty of Law. I choose this one, and you see it goes down to a low 22%. And this has to do actually with the publishing behavior of the lawyers in Switzerland. Now we can, and it's especially low if you compare, for example, with the Institute of Physics. I can choose here in a second. Institute of Physics. I'll probably have to change that. I mistyped, of course. Physics Institute. They have a very high open access share of 90%. We can now go a step further and ask, so what has been published as gold open access within the Faculty of Law, and look at journals and publishers. So actually, which journals and publishers are gold journals? So we filter here for this value, and we go to another dashboard to publishers and journals. And then we immediately see, okay, there are 2 main publishers and some more. And there's one journal which is called Sui Generis. And you can go further there in the tree map, click on the tree map, and say, what are the top 100 researchers? Ask what are the top 100 researchers that have published in this journal. And then you will see here a table. So it's Tom and Mark who has published 17 documents. That's one of the use cases. You can use it for comparison. We will take the example of Mark Thoman and just ask. So we go to the authors dashboard and just ask, so what has he published, and actually what is his open access share? So we go there to this drop down, we are searching for Thoman and Mark. Just scroll up a little bit. I choose this one. And you see there was a second version of his name. And this is one with this ORCID ID, so this specific researcher ID, which is like general ID, so that really distinguishes him from other Thoman marks, if some of those would exist. Okay. Apply the changes. And then I see his share, and actually is one of the few lawyers who has really a high open access share. So his share is 80%, much higher than the Department of Faculty of Law. And just opening here, so then just getting all the publication, and it's even 84.5%. A few of the publications, of course, have to be closed because it published in such journals. But this is a really good share. The last use case I wanted to show, it's again, we can also ask very special questions. And for these, we need the filters. Let's go back there. And I'm just asking how many of the publications have been paid or funded by the Swiss Science National Fund. So I can't do it directly via the drop-downs, but here I can add a filter. And there are a lot of fields we have used, and there is one which is called APC Funder. And all these fields are described in the search tips and help. So I choose this one, choose the operator is, and then I can call the Swiss National Science Foundation Fund, save it. And actually, the open access share should be 100%. And it is not. It should be 100% because the funder requires that everything be open access. And that's a policy of the Swiss National Science Fund. So we can ask which publications are not open. So there are actually a few that are closed. And this is something for the Kibana developers. Here I can't click. The latent is too high, and you see that actually the menus are overlapping. So this should be fixed in this. So I have to choose here the closed. The closed value, and then I can go to the last dashboard, to the Sora items, and I directly do have 2 entries, and even can click there, then to go back to the entry within Sora, and you see it's closed, and actually an accepted version had been deposited here in this record. Just a little thing we can't do today, but this is also made, the database is made with Elasticsearch. Okay, so that was the demo. Let's go further. Yeah, thank you. So what's the technology? It's quite similar. So we use similar indexing software as with Sora, but we use a special open access monitor plugin and script, which we just copied over from Sora, but has some differences. What the difference is, so the Elasticsearch index data structure is flat because Kibana requires it for the aggregations. We only serve the metadata and don't excerpt the full text, but we have many more aggregations than Sora. We calculate them on the fly. They may also combine several fields within Sora and conditions, and also may query during the index in additional sources so that we are doing currency conversions for costs or ask for journal data. What you have seen in the web browser, actually, was the web content management system of the University of Zurich, and we just embed iframes, which are served from Kibana via public space, and then we just translate the URL using an URL proxy. Some tips and tricks on creating dashboards. There is a very nice tool, which is just the graphics on which chart type to choose. For example, if you want to show distribution or if you want to show relationships, you get some hints there which chart to choose. And then another experience I made during creating the visualization and dashboards. So if you're doing such creating such dashboards, then there may be many, and a good naming scheme helps to find them efficiently and also for sorting. And just took a naming scheme such as project, and if it's on production or test, what type it is, what data is described, and then the language, because it's in German and English. So for example, OMP-OEE means it's a production dashboard of the open access monitor, of course, and it displays the organizational units in English. And we have control visualization in German, for example, or we have a vertical bar percentual visualization, VBAR-P, which displays the open access share versus the publication year in English. These are examples for such names. This just is for documentation, the drill downs, how the dashboards are related. Then quickly to the cluster for the production service. we use 3 Elasticsearch virtual machines, each with 16 GB RAM, 4 cores, and 500 GB disk space. Then in addition, there's a virtual machine for Kibana for the admin interface. And for the test environment, we just have a single node installation with the same features, 60 GB RAM, 4 cores, and 500 GB disk space. So we come to the summary. We went live with Zora on Elasticsearch with a beta in the first quarter of 2021. And this was used to get some feedback by the users, and then we were able to complete all the functions, especially the export, did some bug fixing, and also Jens especially then he added field aliases so that you can search for example, things like this publication year or PY. And then we finally went live early second quarter in this year. For the open access monitor, we went live in the end of the second quarter, 2021. There are still things missing. So still we have to do some searching, but also what we want to have are some pivot dashboards. So for example, then that you can show the top authors by open access share by publication year. And there we are still experimenting. So should we calculate these figures outside, or should we use scripted metrics within Elasticsearch? And there are more projects to come. So what currently is running or thinking about is launching a new website, and actually the search engine of the university, so the search engine should be replaced as well. And the open access monitor itself has arisen interest among the institutes in data visualization on web. I think there are at least 2 projects going on. One I cannot tell, and another one. So there's interest actually by the faculty of law to use it, some dashboards of the open access monitor within their intranet. Okay, that's it. Thanks a lot for your interest. So do you have any questions?
So first off, thanks a lot. Are there any questions? If you have any questions, don't hold back. Type them in chat so we can pick them up. One of the funny observations I had. Okay.
Sharing stop.
You're taking over the QA part.
Whatever you want. I stop die Freigabe.
No, I have stopped the screen share already. It's just us.
Okay. So we see each other.
I can even make us a little larger, or no, then I'll cut you off. So I'll keep it like this. So yeah. What I found funny is when I looked at the UI of your tool, it kind of reminded me of Facebook from like 10 years ago.
Yeah, probably.
Let's say this was not the inspiration. No, because I think Facebook had the kind of like the same color scheme, and it had like this like the option to choose or like filter before. But I guess it's just a good UI.
It's a color scheme of Zora, yes. It's a color scheme in a way of our university. So our university has a web intrusion, a web interface like Facebook 10 years before. Yeah.
Fair enough. Well, hopefully it's getting you better results than Facebook, so that's fine then.
No, Facebook is quick too. Yeah.
No. Sorry, not. I meant more in terms of quality, not in speed.
Okay. Yes.
Yes. the research you're getting there. So I was curious for the re-indexing. You always pull all the data from the source from MariaDB, right?
From the Zora metadata to
yes,
the Elasticsearch index or what? Yes, it's a mixture. We decided which metadata is really interesting. Some metadata is generated on the fly, and yes, it's more or less the same metadata except the part of the documents itself, so images or things like this.
Right, but you're not or never doing a reindex within Elasticsearch, just to keep based on the source, you just change the mapping. That's normally not what you do.
No, Reindexing is driven by an indexer in our repository, which is doing something like a stack, and which is making change events to the Elasticsearch. Or what do you mean? Now, the single point of changing something is a submitter or an editor, which is changing some metadata in our repository, and this will be also overtaken or given to the Elasticsearch.
Okay. But you're always coming from the source, basically. You're not, because Elasticsearch has this underscore reindex in endpoint as well. If you just change the mapping, and then you can reindex.
Just to be clear, we don't have any robots or things like this. We know when the workflow changes the metadata, and then we inform Elasticsearch.
Okay, and then that's how you push.
That's a very direct way.
Fair point. We have an attendee question from unused username etrolol. How complex is the ES-Zora proxy?
Yeah. Sorry, we just have one. We don't have speakers in our room, so everybody is. I have to take over. So the proxy it's nothing. It's taking a JSON string, which is coming from the UI, and it's just making the logging and the authentication on the way to Elastic. And on the back way, we also no, it's simply one-to-one. And on the back way, we add some language-specific things, some phrases. We sort something in a different way, or we add some information like the citation, because we decided to put things inside the Elastic index, and the other things are part of Zora's work. So it's a UZH member. We have to show different things like when it's a guest. So the Zora is just the Zora proxy is just deciding, are you a staff member or are you not, and in which language we want to discuss, and then it's changing the behavior of the phrases and then showing things from this. So more or less, it's a plugin in our repository, and it's straight some 100 lines of code written in Perl, because our repository is a very old one and it's written in Perl.
Well, I guess as long as it works, we're not shaming Perl.
There's a fantastic community. There are some CPAN modules for Perl, just always on the newest and freshest version of Elasticsearch. So we just did an update this morning to the new version 7.15. Yes, and if you are doing a new version, it just needs a couple of days, and the Perl libraries are there.
Yes, that is luckily done by our colleague Enrico in Italy, and he's.
Yeah, I think it's a Portuguesian. No, it's Enrico. Nee, wie heißt der? Enrico. I think he's from Portugal. I don't know. It's not necessary.
He's from Italy. Somewhere in northern Italy.
Okay.
He's maintaining the PHP and the Perl clients.
And the PHP. Okay.
Yeah, so he has both of those. So.
Okay.
But he's normally pretty quick to get them out. Okay, so the proxy is pretty simple and mostly like doing some security, doing some minor rewriting and logging.
Yes.
Yeah. And it also makes sense not to expose your Elasticsearch directly, what you should never do. So, yeah.
Yes, because, the Elastic graphical user interface is part of our Zora presentation. So it's just a small React code, which is in our repository, CMS, and it needs to know in which language our customers are or want to show all these results and things like this. So Elastic doesn't know anything about the end client.
Yeah, no, that totally makes sense, and I think from a conceptual point of view, that's also the way we would like to keep it, because Elasticsearch is doing what it's doing, but it doesn't need to do all that other stuff.
Yes,
it's always only.
Yes, and it's very fast, therefore.
That's good to hear. I mean, you have a reasonable size or a reasonable amount of data, not huge, but something that I think is a good fit for the use case with Elasticsearch. Should we do a question
to Kibana?
Martin as well?
Yes, I will.
So yes. So just to include you, for questions. And I'm not sure I have another great question, or if somebody from the audience has one. But for all the indexing data, you said that it's taking approximately 24 hours?
It's taking more for the Kibana index.
Okay. So,
yeah,
so
for the Zora index, it's taking 24 hours.
Okay. And then the logging from the proxy is what is generating the graphs with all the stats?
No, actually the stats are made from the metadata within Zora and additional data we are doing on the fly. So also we are using this indexing plugin, which is the large part. So Jens said it's his proxy is about a few hundred lines, but actually all the indexing methods are taking much more code to produce the data.
Okay.
Yeah.
Cool. And how easy or hard was it to build all the dashboards? Because I sometimes get into discussion with people like, is it hard or easy to build those with Kibana?
I made a course. It's really, I made a course, a Kibana course for the visualizations, and this was a 4-day course in this case because it was online. And this really helped a lot to dig into all the details, and there are lots of hands-on exercises to create the dashboards. And this course I made maybe 3-4 months before I actually started then building dashboard. So again, you stand like the how do you say, the elephant before a small door or so, but finally you remember it, and then but I really recommend to do the course, to visit this course. You will work much quicker. But I think now with the lens tool that you have, I haven't tried out because we were more thinking about single visualizations that can be reused. So I first built the visualizations, then I put them together in the dashboard. But if you are starting with Lens, so you can immediately build the dashboard from scratch and add the visualizations. This, of course, I think with newer versions makes things much easier. Yeah.
Okay, so hopefully we'll keep it easy for the future.
Yes, of course.
Hopefully.
Yeah.
Any final words you want to add? Either one of you?
Yes, it was a lot of fun to work with Elasticsearch, and it was really the tool we needed, both Elasticsearch and Kibana. And I think, or I hope, that within the university that it will really open new pathways also for other data visualizations. And so we are really thinking of or hoping that we can make a service out of it.
Cool. That's great to hear. Thanks a lot for joining us. If you have other cool stories in the future, we're happy to have you back. We'll share the recording afterwards. Enjoy the rest of your evening.
Thank you a lot. Bye.
Thank you. Goodbye.
Bye.
I'm trying to end the broadcast, but my button is broken.
Bist noch da, Philipp?
Ja, aber ich glaube, unser Broadcast auch.
Dann halt ihn mal an.
The broadcast
Stop
is
the
not
broadcast.
ending.
Endless broadcast.
The endless. This is slightly ridiculous. Okay, let me.
Bist du noch da, Philipp?